In this activity, we're going to learn how to find angles that are formed when you have intersecting chords, when you've got secant lines and you got tangent lines. So first, some vocab. A secant line is a line that intersects the circle twice. And I should mention that this is on page 10 in your packets. So any line that hits the circle twice, we would call a secant line. If a line just barely grazes the circle and hits it in one spot, that is referred to as a tangent line. All four of these angles in this picture are formed when two chords crisscross. Chords, remember, are line segments whose endpoints are on the circle. It is important to note that E is not at the center of our circle. If it was at the center, then the angles would just equal the arcs that they open up to. But they're not. So when you do your angle formed by crisscrossing chords, let's look at just one of them. Let's look at maybe this angle 3 here. So we're going to look at this case. So angle 3 is equal to 1/2 of the arc of AD plus the arc of BC. So what I like to think of it as the angle that's formed by crisscrossing chords is just half the sum of its arc and its vertical angle's arc. Essentially, you're taking the average of those two arcs. When you add two things and divide by 2, that's the same as taking the average. The next rule we have in this video is when we have a chord and a tangent that are meeting. When a chord and a tangent meet, the rule is just the same as that of an inscribed angle. So angle 1 and angle 2 here would just be half of their arcs. So for example, if this was 90 degrees for the arc, angle 2 would just be 45 degrees. So a tangent and a chord, just basically a special looking inscribed angle. It's the same rule as the inscribed angle, I should say. The highlighted parts, remember you can put in your packet where the blanks are. And our third rule for today, there's 3 different ways the picture can look, but the rule is the same for all of them. The left-hand picture, you have 2 tangents. The middle picture, you have a tangent and a secant. And the right-hand picture, you have 2 secants. Notice in all 3 cases, an angle is formed that is outside the circle. That's how you would recognize this scenario. You've got an angle formed outside of the circle. In all 3 cases, think of the angle as gobbling up 2 arcs, like the angle's a mouth. Each of those angles is gobbling up a bigger arc, which is the one that's further from the angle, or I like to sometimes call the outer arc. And then it's also gobbling up an inner angle, which is closer to the arc. In all 3 cases, our angle is just equal to 1/2 the outer arc minus the inner arc. So y is the outer, x is the inner. And because we know our angle should be positive, the outer is always going to be bigger than the inner. So let's see if we can apply some of these. In A here, we want to recognize this is formed by crisscrossing chords. So our angle, x, is equal to 1/2 the sum of the arcs. So we'll just do 80 plus 40. Adding those together, we'll have 1/2 times 120, or in other words, x is just equal to 60 degrees. Now, x could change which of those spots it was in. Like let's say the x was where the 80 was and we had the 60 for the angle. Then we would have had 60 equals 1/2 x plus 40. And in that case, you would multiply both sides by 2 to get rid of the 1/2 first. Here we've got a chord and a tangent, so our angle x should just be half of the arc. So x is just 50 degrees. And our third case that's new today, we've got an angle outside the circle. This happens to be 2 secants, but remember any of the 3 cases, tangent and a tangent, a secant and a tangent, or a secant and a secant are all the same. We'll start with our angle, and that's equal to 1/2, then in parentheses the outer arc that it opens to, minus the inner arc that it opens to. So that's going to be 1/2 times 110. And half of 110 is just 55 degrees. Both of our next cases are angles outside of the circle. So we're going to start with our angle, and we'll have 1/2 of the outer arc minus the inner arc. So that'll be 1/2 times 70, and half of 70 is just 35 degrees. Now in E, they actually gave us more information than we needed. If there's only going to be 2 arcs, they could really just give us one of the arcs because the other one can be found by subtracting from 360. So say they hadn't given us this 120, but they gave us the 240, we could just do 360 minus 240 to then get the 120. So we might not always get that second arc when you have a tangent. So we'll have our angle equals 1/2 the outer arc minus the inner arc. So that's going to be x equals 1/2 times 120. So in other words, x is equal to 60 degrees. Next one, we want to recognize our angle is formed by crisscrossing chords. We want to find AB, so we're going to call that a variable. We'll call it x. So we always start with our angle in our setup. So we're going to start with the 85 in this case, equals 1/2 times arc plus arc, so x plus 50. The opposite of multiplying by 1/2 can be done by multiplying by 2. So if we multiply both sides by 2, this will give us 170. 1/2 times 2, those become 1, so they go away, and we just have x plus 50. We'll subtract 50 on both sides. We get x is 120. So that means our measure of arc AB is just 120 degrees. In the next example, we've got a tangent and we've got a chord. So this angle here, CBD, which we want for part A, is just the same rule as an inscribed angle. It should be half the arc. So half of 232 would give us 116 degrees. Well, then to find the other angle, ABD, those are just angles on the line. So they should be supplementary. We can do 180 minus 116, and that'll just give us 64 degrees. That's it for this activity. You can go on to activity 5 and pick one of the 2 options, depending on how comfortable you feel with these examples that you just watched.